Very good morning, one and all. Welcome to LMS, Department of Collegiate and Technical Education. I am MB Shadakshari, Selection Grade Lecturer in ENC Department from Government Polytechnic Tumkur. Today we are going to discuss attenuators in analog communication unit 2. In this session we are going to discuss following topics. First, you are going to define what is an attenuator. Next, you are going to classify the attenuators. Next, applications of an attenuators, and then you are going to study how to measure attenuation. For that, you are going to define three parameters: bell, decibel, and Nepper. And then you are going to make the relationship between decibel and Nepper and some assignment questions. After that you are going to see multiple choice questions. Now you are going to study first what is an attenuator. Attenuator can be defined like this. Attenuator is a two-port or four-terminal network connected in between source and load, that means input and output, which is used to introduce a specific amount of loss of current or voltage or power. Or another way you can define attenuator like this. Attenuator is a two-port network which is used to reduce the signal level when it is used between source and load. You can define like this totally. Attenuator is a two-port or four-terminal. Means two-port means in electronic circuit normally you are going to have a input and output are available. They are called as a two-port networks. Or normally you are going to connect input by two terminals and output by two terminals. Totally you are going to have four-terminal network. That such type of network you are going to call it as a four-terminal network. That means attenuator is a two-port or four-terminal network which is used to decrease the strength of a signal, or that is going to, the input signal strength is going to decreased, or that signal strength is going to weakened by the circuit. That type of circuit you are going to call it as a attenuator. See this black diagram. In this black diagram, this is attenuator circuit. You are going to have input and then output. That means it is going to have two-port, or to connect the input you are going to have two-terminal, to connect the output you are going to have two-terminal, totally you are going to have four-terminal. You are going to apply input. Normally input signal strength is high. It may be voltage or current or power that is applied to the circuit, but the output side strength of the signal is going to decrease by using circuit. That circuit you are going to call it as a attenuator. Totally, attenuator is going to decrease the output signal available at the input signal. That type of circuit we are going to call it as attenuator. Easily you can understand using this circuit, output signal is less than input signal. The signal may be current, voltage or power. Normally attenuation is going to measure in terms of power. Next, you can see this figure. This figure is also indicate where you are going to connect attenuator. Now you can see this circuit, this is your input connected between two terminal, output is also connected between two terminal. That means a source and load. In between source and load you connecting attenuator network. Here that is shown here also source and load. Between source and load you are connecting attenuator network. Attenuator is a two-port or a four-terminal network. Now you can define like this: an attenuator is a four-terminal or two-port resistive network inserted between a source and load, which is used to introduce specific amount of loss of current or voltage or power. That circuit we are going to call it as a attenuator. Or another way you can define, it is a two-port network which is used to reduce the signal level when it is used between source and load. Like this you can define our attenuator. Normally our attenuator circuit is designed using resistors, otherwise resistances. We are going to use it to construct our attenuator to get required amount of attenuation. Next, attenuators. The attenuators can be either fixed type or variable type. Normally, the attenuator is going to produce constant attenuation is called as a fixed attenuator. It is going to give variable attenuation means is called as a variable attenuator. An attenuator which provides constant attenuation throughout is called pad. That means attenuator is going to give the constant attenuation throughout its operation. That type of attenuators you are going to call it as a pads. The power loss in any network is represented by attenuation, and it is represented by N, capital N. That means in your attenuator circuit, the output power is going to get less than the input power. That means it is going to decrease the power. That is represented by capital N. Normally we are going to represent attenuation in terms of power loss. For normal attenuator circuit, you are going to measure the attenuation in terms of these three terms. You are going to use Nepper or bell or decibel. Normally is represented by dB. These three terms are going to use it to measure the attenuation of a attenuator circuit. Next, you are going to study classification of attenuators. You can classify our attenuation in so many ways, so many types. You are going to see one by one. In type 1, you are going to classify our attenuators into two types. In that first one, fixed attenuator. The fixed attenuator means the attenuator circuit which gives constant gain, constant attenuation or fixed attenuation. That type of attenuators you are going to call it as a constant attenuator. To design this attenuator, you are going to use normally a fixed resistor values are going to use it to construct that circuit. That type of attenuator you are going to call it as a fixed attenuator. In that second type, variable attenuators. The variable attenuator means the circuit is going to give variable attenuation. That type of attenuator is called as a variable attenuator. Normally these variable attenuators are constructed using variable resistors. Next, based on the property of a circuit, you can classify our attenuator into two categories: symmetrical attenuator and then asymmetrical attenuator. Symmetrical attenuator means the input and output resistance or impedance of a circuit are equal. That type of circuit you are going to call it as a symmetric network. If it is applied to attenuator, you are going to call it as a symmetrical attenuator. That means you can define like this: symmetric attenuator is a resistive network connected between source and load. It is having a equal input and output resistance. That type of attenuator we are going to call it as a symmetrical attenuator. Asymmetrical attenuator, it is a resistive network connected between source and load having unequal input and output resistances. That type of circuit we are going to call it as a asymmetrical attenuator. Now you can see what is the meaning of symmetrical and asymmetrical is explained with respect to this circuit diagrams. You can see in symmetrical network, the input is going to have a Z0, output is also going to have a Z0. That means input resistance or impedance is equal to output impedance or resistance. That type of network we are going to call it as a symmetrical 4-terminal network. The same thing is applicable to attenuator. We are going to call it as a symmetrical attenuator network. Asymmetrical means from input side you are going to have Z-01, output side you are going to have Z001, and from output side you are going to observe you are going to get Z002. From input you are going to get Z-02. That means Z-01 is not is equal to Z-02. They are not equal. That type of network you are going to call it as asymmetrical. If you are designing attenuator like that attenuator we are going to call it as a asymmetrical attenuator. This is the difference between symmetrical and then asymmetrical network. In our syllabus you are studying symmetrical attenuators, especially you are going to study symmetrical T type and then pi type attenuator studying in our syllabus. Next, depends upon construction of a attenuator, you are going to have many classic types are available. Here some are there listed here, depends upon arm and then shunt impedances. You can classify our attenuators as follows: T type attenuator, pi type attenuator, lattice type attenuator, bridge type attenuator, L type attenuator. Now you can understand why that particular attenuator is called as a T type, pi type, lattice type, bridge type. Using this figure you can easily understand. In case of pi type, here register R1, R2, R2, they are connected in the form of the Greek letter pi. So this circuit we are going to collect as a pi network. Now in this circuit we are going to get output is less than input. That circuit we are going to collect as a pi type attenuator. That means this circuit look like a pi, so it is called as a pi type attenuator. This here you can take R1, R2. This particular structure you are going to collect as a lattice. This construction of circuit you are going to collect as a lattice type attenuator. Here the circuit components R0 and then RA, RB, they form a bridge. So this is called as a bridge type attenuator. And then here resistor R1 and R2, they connected in the form of a L. So this is called as a L type attenuator. So depends upon how you are connecting our circuit components. Based on that you can classify that attenuators. Okay, next, applications of attenuator. Wherever in our, especially in our electronics, where we want to reduce the input signal to lower value, you are going to use attenuators. In some, especially some applications, you want to decrease the strength of input signal. In that situation, you are going to use these attenuators. Now some of the applications are listed here. We are going to take one by one. The applications of attenuators are like this. The attenuators are used in resistive impedance matching circuit. Sometimes source and load, they are not matching each other. In that situation, you are going to use attenuator to match our source with load. Next, attenuators are used as volume control equipment in broadcasting. In almost all volume control applications, you are using attenuators. The attenuators are used in testing purpose in laboratory to obtain small voltage or to get small current. You are going to use attenuators. Fixed attenuators are used to improve the impedance matching in circuits. Already I explained, impedance matching is to match the source with load. You are going to use the attenuators is used in such applications. In high frequency transmission lines, the resistive attenuators are used, and optical attenuators are applied in fiber optic communication in proper matching transmitter and receiver levels. In optical communication also nowadays you are using attenuators. Like this you can use our attenuators in many applications in your communication related applications. Next, how to measure this attenuation in our electronic circuits. To measure this attenuation, you are going to use three terms: bell, decibel, and then Nepper. You are going to define what is bell, what is decibel, what is Nepper, and then you are going to make a relationship between decibel and Nepper. First, I am going to define bell. Bell is a unit to express gain or attenuation in logarithmic of base 10. That means bell is represented in logarithmic base, otherwise base 10 you are going to use to represent our bell. For attenuation, we can define our bell like this. Bell is defined as logarithmic ratio of input power to output power. Equation in the form of equation, write like this: bell is equal to log base 10 pi by p naught, where pi is input power, p naught is output power. You can define bell, otherwise you can express bell in terms of power. Next, decibel, normally denoted by dB. Decibel is smaller unit used to express attenuation or gain. Decibel is defined as 1/10 of the bell, or 10 decibel is equal to 1 bell. In the form of equation you can write like this: 1 bell is equal to 10 decibel, or decibel is equal to 10 log base 10 pi by p naught. Here also pi is input power, p naught is output power. That means decibel is equal to, or dB is equal to 10 log base 10 pi by p naught, where pi is input power, p naught is output power. Next one is how to here is seen how to express our power related to decibel. Similarly, how you are going to express decibel in terms of voltage and current. You can see here in terms of voltage ratio, you can possible to write decibel. Now you have seen the power is equal to current into voltage. You can express power is equal to voltage square divided by R. You can write input power PI is equal to VA square divided by R square, and then P naught square is equal to V naught square divided by R square. Substituting in this equation, you are going to get VI divided by V naught whole square. Using logarithmic property, you can write dB is equal to 20 log base 10 VI by V naught. That means you can express the voltage ratio also in terms of decibel. Otherwise, decibel you can represent in terms of voltage also. But in case of power, this value becomes 10. But in case of voltage, this value becomes 20 log base 10 VI by V naught. Similarly, you can express decibel in terms of current. We know the relationship between power and current. Power is equal to current square into resistor. You can substitute input power is equal to input current square into resistance. Output power is equal to output current square divided by resistance into resistance. Resistance cancels. I divided by I naught whole square. Now we can, using logarithmic property, you can write dB decibel is equal to 20 log base 10 I divided by I naught. Like this, you can express our decibel in terms of power here, 10 log base 10 Pi by P naught in terms of power. In terms of voltage, dB is equal to 20 log base 10 Vi by V naught. In terms of current, dB is equal to 20 log base 10 I divided by I naught. Like this, you can express decibel in terms of power or current or voltage. Next, you are going to see Nepper. The Nepper is a unit to express the gain or attenuation on natural logarithmic scale. Previous two are represented in logarithmic scale. This one is natural log. Nepper is defined as natural logarithmic ratio of current ratio or voltage ratio. Now you can represent our attenuation is represented by N. Nepper N is equal to log E, log base E N, otherwise log N base E. You can write in the form of equation like this. Here N is Vi by V naught or II by I naught. In the form of an equation, you can write Nepper is equal to log N base E, where N is input voltage by output voltage or input current by output current. Like this, you can define Nepper. Next, you are going to see how to represent Nepper in terms of dB or dB in terms of Nepper. Here you are going to make relationship between Nepper and then decibel. Now in the previous slide you seen, you can represent our decibel in terms of current or voltage. The decibel D is given by 20 log base 10 N. This is a fundamental or basic equation to represent decibel in terms of current or voltage ratio, that is called as equation 1. Now attenuation in dB can be written in terms of natural logarithm. You can write this equation base 10, you are splitting into natural logarithm. You can write like this: D is equal to 20 log N base E into log E base 10. You can split this like this using logarithmic property, and then for this quantity you can calculate log E base 10. That value is nothing but 0.434, and then multiply these two quantity, you are going to get decibel D is equal to 8.686 log N base E. This is an expression for representing decibel D in terms of Nepper. Log N base is nothing but Nepper. Here D is decibels. This is a relationship between decibel and then Nepper. Attenuation in Nepper is defined as Nepper is equal to log N base E. Substitute into this equation, you are going to get attenuation in dB is equal to 8.686 into attenuation in dB. Otherwise, you can call it as a dB is equal to 8.686 Nepers, or attenuation in Neper is equal to 0.1151 attenuation in dB. Otherwise, in the form of equation, you can tell like this: Neper is equal to 0.115 dB. Like this, you can make a relationship between decibel and then Neper. This relationship is very important, and then derivation is also very important from your examination point of view. Next, you are going to have some assignment question. Whatever the things you studied up to here, some of the question listed here, you have to write an answer for these questions. First question, write a note on attenuator. Second question, mention the applications of attenuator. Third one, define bell, decibel, Neper. Next, fourth one, classify the attenuators. Fifth one, derive the relationship between decibel and then Neper. This type of questions they are going to ask your examination. You prepare the answer for this with referring above answers. Next, you are moving into multiple choice questions. That means MCQ questions. I am going to read the question. I am going to give 3 to 5 seconds. You note down your answer. After that, I am going to give correct answer. You compare your answer with my answer. First MCQ question. The attenuation in dB in terms of input power P1 and output power P2 is options: A, log P1 by P2 base 10. Second one, or B, 10 log 10 P1 by P2. Third one, log P2 by P1 base 10. D, 10 log base 10 P2 by P2. P2 by P1. Okay, correct answer is B. In this case, 10 log base 10 P1 by P2. The input power by output power ratio, logarithmic base 10 of that value into 10. In case of voltage, this becomes 20. It is a main difference. The next one, if V1 is the voltage at port 1 and V2 is the voltage at port 2, then the attenuation in dB is option A, 20 log base 10 V1 by V2, 10 log base 10 V1 by V2, 20 log base 10 V2 by V1, 10 log base 10 V2 by V1. Especially attenuator, input by output. You have to take input port is port 1, output port is port 2. For this, correct answer is A, 20 log base 10 V1 by V2. Next, what is the attenuation in dB? Assuming I1 is the input current and I2 is the output current leaving the port. Options: A, 10 log base 10 I1 by I2, 10 log base 10 I2 by I1, 20 log base 10 I2 by I1. Fourth one, 20 log base 10 I1 by I2. For this, correct answer is D, 20 log base 10 I1 by I2. In case of power, this becomes 10. In case of current, 20 log base 10 I1 by I2, or in terms of voltage, 20 log base 10 V1 by V2, where V1, I1 are input current and voltage, I2 and V2 are output voltage and then current. Next, third one, why are the variable attenuators applicable for radio broadcasting purpose? Option A, for speed control. Option B, for volume control. Option C, for time control. Option D, for power control. Especially the attenuators are used in radio broadcasting for volume control. That correct answer is B, for volume control. Next, fifth one, which resistive network connected between source and load having unequal input and output resistance? Option A, symmetrical attenuator. Option B, asymmetrical attenuator. C, fixed attenuator. D, variable attenuator. Which resistive network connected between source and load having unequal input and output resistance? For this answer, correct answer is asymmetrical. The input output, they are equal. Symmetrical, they are not equal. Asymmetrical, that means answer B is correct for this question. Sixth one, Which resistive network connected between source and load having equal input and output resistance? A. Symmetrical attenuator, B. Asymmetrical attenuator, C. Fixed attenuator, D. Variable attenuator. That means the network having equal input and output resistance, they are called as a symmetrical attenuator. So option A is correct answer for this multiple choice question. Next, you are moving into 7th question. Variable attenuator exhibit variable attenuation but at constant dash input impedance, output impedance, both A and B, and D none of the above. Especially in case of variable attenuator, the attenuation is changes, input and output impedance, they are not going to change. That means variable attenuator exhibits variable attenuation but constant, it has an input impedance, output impedance. So for this question, answer is C, both A and B. It is going to have constant input impedance, constant output impedance. So option C is correct for this question. 8th, which type of attenuator provides a fixed amount of attenuation by allowing the user to vary the attenuation in multiple steps? A. Lattice attenuator, variable value attenuator, pad attenuator, D. All of the above. For this, correct option is A. Ladder attenuator. 9th one, dash is mathematically equal to the logarithm to the base 10 of power ratio P1 over P2. P1 divided by P2, that means bell, decibel, bell by 10 or dB by 2. For this, answer is bell. Bell is equal to, the bell you can define using above equation, logarithm of base log base 10 P1 by P2 is correct as a bell. That means correct answer is A, bell. Okay, last MCQ question. 10 decibel is equal to A. Decibel, B. Bell, C. Nipper. For this, correct answer is bell. Bell is equal to 10 decibels. Now these are the some of the reference book given here for enhancing knowledge about attenuators. You can refer these books, or also you can possible to go to this YouTube and refer this link to enhance your knowledge. Okay, thank you.